Before I forget, is this a stereocenter? No. That's why we did have to worry about the wedges and the dashes over here. So this is a very common pattern in OChem. Very often, after you do the main reaction, you have to protonate or deprotonate to get rid of the charge that developed. So if you do your main reaction and you see you've developed a charge, you should ask if you can protonate or deprotonate to get rid of that charge. Okay. Did you ever look at the series of videos I have on the 3 types of SN2?
Yeah, I went through all of your series of videos on
Okay.
SN2, SN1, E2, and E1, and then I started the E1 or E2 series.
Okay. I also have like a just a 1 10-minute video on the 3 types of SN2. And anyway, this is what it covers here. This is like the 2nd type of SN2. If you end up with a positive charge, you would deprotonate. Okay. And for the most part, again, you actually were working this out. You just weren't comfortable with this last deprotonation step. Okay, let's try drawing the mechanism here. If you feel that you get stuck, we can go through it together. Okay, so you've got some things right and some things incorrect, so let's work on that together now. One thing we're going to want to do is, again, try to use our chart to figure out what the right mechanism is here. So let's look, see, one thing that you did that was good is you labeled the alpha carbon. So here we have our alpha carbon labeled. Now is this primary, secondary, or tertiary?
Secondary.
And how do you figure that out?
Because it's surrounded by 3 other carbons, correct?
And that, what does that make it, primary, secondary, or tertiary?
Secondary.
Now actually, and what would make it primary?
Primary, just 1.
And secondary?
2.
That's right, but I think you were thinking the secondary meant 3.
Yes.
Okay, so let's review that a little bit. So,
you're right.
It turns out that the natural meaning of the words is exactly what they mean in this context. Primary means you're attached to 1 carbon chain. Secondary means you're attached to 2 carbon chains. Tertiary means you're attached to 3 carbon chains. That's actually really important to why, I'll remember to come back to that. But you see why we would think of this as tertiary, because it's attached to 3 carbon chains. A good symbol for that is this. This is the standard symbol for tertiary. Okay, so we could label this as tertiary. And so which row of the table would we be in?
We're going to be in the last row.
The last row, our tertiary row. Okay, now we also have to identify the nucleophilic atom. Well, who is the nucleophilic atom here?
The oxygen.
Good, except we have to get into the habit of identifying both the atom and its charge. So what's the charge on our nucleophilic atom?
It's neutral.
Neutral. So let's see if we can find a neutral oxygen in the table.
Yes.
Good. So what's the reaction going to be?
So it's going to be either an SN1 or an E1.
Yeah. Now that SN1E1 slash, that's a little explained here at the bottom. SN1 slash E1 means both SN1 and E1 occur.
Okay.
However, which one do we get more of?
SN1.
Way more of.
Yeah.
So actually, in many contexts, you wouldn't even bother drawing the E1.
Correct.
It kind of depends on the textbook and the instructor. But many instructors here would just draw the SN1 because you can see the ratio underneath the table is 95 to 1. So there's way more SN1.
Could you draw, if it's not specific on a test, could you just draw the SN1 accurately and then maybe mention a small amount of E1 reaction will occur too? And if you draw the
Kind of, yeah.
It seems like if you drew the reaction correctly, then you would
Right.
assume that you know what you're doing.
Right. Well, it depends kind of on how the question is worded. And basically what you have to do is you have to look at some, hopefully your instructor would give you past sample exams with answer keys, and then you'll see what types of things he's drawing, and you'll see whether he usually draws the E1 in this case. Okay. Anyway, for right now, let's just do the SN1, and then once we have that under our belt, maybe later we'll go back to the E1.
All right.
Okay. So this is going to be an SN1 reaction. Now, how many steps are there in an SN1 reaction?
2.
Yeah. And how many steps are there in an SN2 reaction?
1.
Good. Let's go back to the SN2 reaction for a second.
All right.
What happens in an SN2 reaction?
The nucleophile does a backside attack while the leaving group simultaneously leaves.
Good. That's well put. So in an SN2 reaction, the nucleophile attacks and the leaving group leaves simultaneously. Nucleophile attacks and leaving group leaves simultaneously. Now, in SN1, there's 2 steps. So what happens in the first step?
The leaving group leaves.
And what happens in the second step?
The formation of the carbocation. It's the intermediates, the carbocation, and then the nucleophile will can attack from several directions usually, and you get a racemic mixture.
Okay, good. So let's boil that down. In an SN, so what's happening here is I'll actually write this down in words. In an SN2, the leaving group leaves, and the nucleophile joins, and these things happen simultaneously. Whereas in an SN1, first, the leaving group leaves, and then 2, separately, the nucleophile joins. And the important thing to see is that these are the same precise things that happen in an SN2. It's just that in an SN1, they happen sequentially, and in an SN2, they happen simultaneously.
Right.
So we're going to do the same exact things we would have done if this were an SN2, just sequentially. So the mistake that you made when you were working through this is I think you were showing them happening simultaneously. Well, which one happens first here?
The leaving group's going to leave.
Right, so at this point, we should only draw the arrow for the leaving group. We should not draw the water attacking yet, because this is an SN1. That was the main problem with our first approach. Okay, good. So let's see if you can draw the intermediate from that. Good. What was the other product of that step? Okay, that's fine. Okay, so the leaving group is gone, and we have to change 2 charges. Well, the carbon was at the initial tail, so it becomes positive, and the iodine is at the final head, so it becomes negative. So that's what we do there. And by the way, that means we formed the carbocation. So notice that the formation of the carbocation is not a separate step. The formation of the carbocation just happens naturally when the leaving group leaves. When the leaving group leaves, that naturally forms a carbocation. So we don't need to list that as a separate step. Okay, let's see if we can draw the mechanism for the next step.
Would we draw it in this? I'm getting a little bit confused and Should I have brought water over to the intermediate step that I have?
That's kind of a matter of taste. So what you did is you took these intermediates and you redrew them all over again as new starting materials, but you can actually save time. So one thing that some people might do is they might take the water from over here and show it attacking.
Okay.
That would be perfectly legitimate. Or if that kind of gives us a great big arrow there, so maybe to get less of a big arrow, we could recopy the water.
Okay.
And draw it over here.
Right.
And there isn't really any need to redraw this intermediate because we already got it over here. So either of the things I have on the board would be acceptable.
Okay.
And it's good that you drew in the lone pair on the oxygen for the arrow, for the tail of the arrow to be coming from. We actually only have to draw one of the lone pairs because it's only donating one lone pair.
Correct.
Okay, well then we should go ahead and draw the next intermediate.